The idea was to make a difference, to actually go in there and you've done something that's worthwhile. 2006, 2008, I was actually doing installation work in hospitals throughout the UK, and there was an issue with wards that were repeatedly going down with MRSA or with E. coli or with problems. So I set about an idea at that time, but unfortunately it died a death. And then come COVID, a friend of mine said, would that device that you were looking at a few years ago be useful against COVID? And the big thing really was to make a device that was small enough to be utilised anywhere within a room or a building, that went away from light bulbs, which are traditionally fitted to air purification devices, but to go to LEDs. So they were the main goals.
When I started at Filtrase, I had no idea about this product. My background is mechanical engineering, so there's a bit of a learning curve for me to understand the technology behind the product. Once I familiarised myself with the basics at that time, it became evident that we needed to move forward with a plan for testing. Because a lot of these papers refer to testing. And David was using a different technology. He started to use LEDs rather than the mercury lamps.
Why we came to in the first place was we knew that we could not get accurate results ourselves. With basic monitoring equipment for airflow, wind speed, this, that and the other, that's all we'd got. And it can show you at the beginning what is happening and what is the air movement, and it can show you what the end is happening. It's not showing you what's happening inside. And how are you going to get that residence time? There's no way of measuring it. Not from our point of view, and not to physically see it. Furthermore, when you actually look at the exhaust, which is the most important part from our perspective, you have different airflows at different levels. We didn't know which one was correct, what had we done wrong. And you can only do so much on paper. You can only do so much by a prototype. And when you add and remove things, you don't know if you've made a difference. You've got to know exactly what you've done that has affected the end result. And with CFD modelling, you catalogue everything that you do at every stage with every result, so you achieve perfection.
We did look originally at buying CFD modelling, but given the time factors that were involved and the cost, and also the fact that in any sort of training you have about 6 months of pain where you actually get the confidence to be able to input data and be comfortable with the results. And because CFD modelling is not something that I was familiar with, it did feel at the time that, you know, this is a step too far for me. We need to buy it in. It was the empathy that we found with Solid Solutions to understand what we were trying to achieve. I mean, we weren't trying to achieve F1 technology. We just wanted to know how good the box was.
So in the Carlton Forest project, obviously it was CFD's SolidWorks flow simulation was sufficient for the needs, with a particle study coupled to that. What that allows us to do was track resonance times. We'd do that in certain regions to really understand whether they were getting the molecules and the particles in the regions they needed them to be in to actually have the effectiveness, the kill zone as they call it, which was the place where the LEDs were most powerful and the chemicals were likely to attach or diffuse these, COVID particles or whatever the viruses might have been. So we were able to track that. We were then able to validate the velocities at those points, at various points with sensors in the physical test, and we got really good correlation, almost nail on the head on quite a few occasions. There were some occasions where there might have been small discrepancies, but then we'd look at it and say, right, well actually realistically we've got our sensor perhaps in the wrong place, or we're measuring this, or we've got a slightly different fan, and there was a few variables. So once we worked out what the difference was between the virtual and the physical, we corrected it, and we then, again, really close. I think it was in 95% accurate.
At this moment in time, we have developed the device really going forward with sensors and being able to say at any one time what is happening with the air in that room, which, as we know, we just can't put a great big block inside there without considering the airflow. We've had to consider very carefully what we can put in, what size we put in, and where we go with it.
And I think the next stage will be whether we look at producing an app so people can actually interrogate the unit and see for themselves from a visual perspective, i.e. graphs. We're also exploring the Amazon Alexa, which would actually just tell people, or you could interrogate it that way. Get Alexa to say, well, yeah, just open a window, or your air quality's not so good today, maybe you want to think about switching a few units on. And I think that would be a more subtle way of controlling the unit without panicking people.
It just doesn't stop here, because the need for air purification in the place of work and at home to keep everyone safe.